Today I am going to create a simple networking, a small business networking project uh, in which there are several PCs that are communicating with different VLANs, also IP phones connected with different departments so they can communicate with the different department. Also the feature of inter-VLAN routing and VTP. I also have a server switch and client switches and a single VLAN router that provides a DHCP feature so that all the PCs and IP phones are configured with automatic IP address. So I am going to take a router that will be Cisco 2811 router, and this router first I'm going to create a topology for this network. Now I'm going to take a multi-layer switch and one access switch. This switch for is IT department, and this switch is for finance department, and this switch is for HR department. Now this switch is a layer 3 switch, and these switches are the layer 2 switches. Now I'm going to take two PCs for IT department and two PCs for uh, finance department, also two PCs for HR department. And I'm going to take IP phone for each PC. Now the time is of connection time. So this router's fast Ethernet 0/0 is connected with a multi-layer switch fast Ethernet 0/1 with a copper straight through cable, and multi-layer switch port fast Ethernet 0/2 is connected with this port with a crossover cable, and this port is connected with also this port with crossover cable, and this port is connected for crossover cable. Now this switch is connected with this switch port, and this PC port is connected with this PC. Now our topology is created. So the thing we have to do here, uh, we have to first configure VLANs to switches for each department. So I'm going to configure VLAN 10 for IT department, and VLAN 20 for finance department, VLAN uh, VLAN 30 for HR department, and VLAN 100 for voice VLAN. And also we are going to configure VTP. So our multi-layer switch will be VTP server switch, and our access switches will be VTP client switches. Now the IP address. So for VLAN 10, the IP address will be 192.168.1.1/24. For VLAN 20, I'm going to VLAN 20. And for VLAN 20, 192.168.20.1 network will be the network will be for 20 network, and for VLAN 30 the network will be 192.168.30.0/24, and for VLAN 100 the network will be 192.168.100.0/24. Now the DHCP service is for this router will provide a DHCP service, and that all the IP phones are configured with DHCP IP address, and also for PCs. Now inter-VLAN routing. So firstly, I'm going to configure a multi-layer switch with VLAN, different VLAN. So switch configure terminal. I'm going to provide a host name as main switch, and configuring VLAN 10, name IT, VLAN 20, name finance, finance, VLAN 30, name HR, and VLAN 100 voice. Name voice. Now I'm going to configure this switch as a VTP service switch, server switch. So the other switches, all the other access switches will automatically configured with VLANs. So we have not to manually configure the other switches with specific VLAN. So VTP mode, VTP mode server. So this switch is already configured with server. Now next thing is VDP domain and VTP password, and we have to also configure the which version of VTP are we using. So we're using VTP version 2, and the VTP domain will be like I'm going to give name like ABC, capital ABC. Now the VTP domain is now a change from null to ABC, and VTP password will be small ABC. So it is easy to remember. Now our VLAN configuration on main switch is done, and now we have to configure all the different department switches with VTP client, so they can access the VLAN. So they can access the VLAN from this server switch. En configure terminal VTP mode client VTP version 2. Sorry, we cannot define VTP version when it is client. So first we have, I'm going to define this is VTP mode server. Now VTP version 2. Now VTP mode client. Now VTP domain, VTP domain capital ABC. We have to give the same domain and password that are that we have given in the server switch. So VTP domain ABC and VTP password small ABC. Now I have to do this thing in all both routers. So en configure terminal VTP version 2 VTP mode client VTP domain capital ABC and VTP password small ABC. Now for this switch, now en configure terminal VTP version 2 and VTP mode client and VTP domain ABC and VTP password small abc. Now the VTP and VLAN are configured. So what we have to do is we have to configure uh, uh, multi-layer switch port 020304 as a trunk port for VLAN 10, 20, 30 and 100, and this port is also will be configured as a trunk port for VLAN 10 and voice VLAN, and this port is also configured with VLAN 20 and voice VLAN. This port is configured with VLAN 30 and voice VLAN. So configure terminal interface range fast Ethernet 0/2 to 4 switch port mode trunk. First we have to configure this port as a .1. So in switch port trunk encapsulation .1q switch port mode trunk switch port trunk allow VLAN 10, 20, 30, 100. Now the thing is here done. For this switch, configure interface fast Ethernet interface fast Ethernet 0/1 switch port mode trunk switch port trunk allow VLAN 10, VLAN 100. Okay, now for this interface FA 0/1 switch port mode trunk switch port trunk allow VLAN 20, 100. Now for this port, configure terminal switch port fast Ethernet 0/1 switch port mode trunk switch port trunk allow VLAN 30, 100. Now also we have to configure also this port as a trunk port because all the traffic is routers goes from all these IP phones and PCs. So this port is also configured with this port is also configured with a trunk port, and all the VLANs must be initialized for this port. Now this interface fast Ethernet 0/2 and /3 is configured with native VLAN 10 for PC and voice VLAN for IP phones, and for this native VLAN for PCs, for native VLAN 20 for this PC, and voice VLAN for IP phones. As you can see that IP phone is not powered on, so we have to give this a power adapter to turn on. So I am powering all the IP phones with external power adapter. So there is also a feature of IP phone, so we can give power supply with power over Ethernet PoE. So there is no need of any power adapter. So it is so on a PoE it is minimum requirement of 15 watt. So it is also a default. So we can power up by power over Ethernet. Now I'm going to configure fast Ethernet 0/1 of multi-layer switch with a trunk port. So interface fast Ethernet 0/1 switch port trunk encapsulation .1q switch port trunk switch port mode trunk switch port trunk allow VLAN 10, 20, 30, 100. Now all the thing is done here. Now the remaining is for these ports. So it's it interface fast Ethernet 0 interface range fast Ethernet 0/2 to 3. Any problem is happened here? So the port number, I think. Okay, the port number will be fast Ethernet. Okay, I will change. It's automatically configuring. I'm going to configure fast. Okay. Oh, the switch. So I have taken a PT switch. That's the problem. Okay, no, not the problem. Now the fast Ethernet 2/1 and 1/1. Okay. So interfaced fast Ethernet 1/1. This port is configured as a trunk port for native VLAN and bus VLAN. So switch port mode trunk and switch port trunk allow VLAN 10, VLAN 100 and switch port trunk native VLAN trunk and switch port voice VLAN 100. Now the configuration is done for this interface, and now for interface fast Ethernet 2/1 switch port mode trunk switch port trunk allow VLAN 10 comma VLAN 10 comma 100 switch port trunk native VLAN 10 switch port voice VLAN 100. For this port interface range fast Ethernet 0/2 to 3 switch port mode trunk switch port trunk allow VLAN 10 VLAN 20 comma VLAN 100 and switch port trunk native VLAN 20 and switch port trunk switch port voice VLAN 100. Now the configuration is done for this switch. For this switch interface range fast Ethernet 0/2 to 3 switch port mode trunk switch port trunk allow VLAN 30 comma 100 and the switch port trunk native VLAN 30 and switch port voice VLAN 100. Okay, now all the thing is done here. Now the remaining is Inter-VLAN routing and DHCP services. So in router configuring configure terminal interface fast Ethernet 0/2. First of all, we have to no shut this interface, that the interface will be turned on. Now after we have to configure the sub interface for Inter-VLAN routing. So interface fast Ethernet 0/0.10 and configuring IP address 192.168.1.1 and 255.255.25.0. So here's the problem. So I have to configure this port is also a .1Q encapsulation. So we can initialize IP address to this port. So encapsulation .1Q and for VLAN 10. Now I can initialize IP address to this port. Now the IP address allocation is completed here. Now same for VLAN 20, 30 and 100. So interface fast Ethernet 0/0/20 encapsulation .1Q20 and IP address 192.168. Oh sorry, there are IP address allocation problem. I have to configure here 1.10.1. So first I have to 20.1 25.255.25.0. So can check that interface is now. Interface fast 0/0.10 and IP address 192.168.10.1. encapsulation.1q for VLAN 30, and the IP address will be 192.168.30.1, and the subnet mask will be /24. Now fast Ethernet 0/0 dot 100 encapsulation dot 1q 100 IP address 192.168.100.1, and no shutdown interface. Now the inter-VLAN routing is completed here. Now now time for DHCP for the DHCP services. So for DHCP, I have to configure IP. So we have to create here pool for different department and also for voice VLAN. So IP DHCP pool, and for IT, so I'm configured with department IP. So now the network will be over here 192.168.10.0, and the subnet mask will be /24, and the default gateway will be 192.168.10.1, and the DNS server will be same as 192. So I am not here configuring a DNS server. So when we add a specific DNS server for this network, so I will configure this. So let's suppose I have a DNS server. Let's suppose this server, and we will connect this server with a port. So now this server's IP address will be let's suppose 8.8.8. So for DNS server 8.8.8.8, and this server will be also we can initialize an external server, but this is an internal server. So if we add an external server for this router, then we can use this DNS server's IP address. Otherwise, this server is also used for an internal work for this network. So now exit from this. Now if we check for VLAN 10, the IP address is configuring or not. So if we go DHCP service, so if you can see that the DHCP request is successful for this PC, and the IP address is allocated to this PC. Now for this PC also, yeah, DHCP request is successful and IP address allocated to this PC. Now for department, finance department, HR department, we have to also configure a specific DHCP pool. So IP DHCP pool finance FINANCE, and the network will be 192.168.20.0 and IP subnet mask, and default router will be 192.168.20.1, and the DNS server will be 8.8.8. So we will configure 8.8.8 server in last after configuring all this network. So I am initializing this DNS server to this DHCP pool, but after all thing is done, this DNS server is not working because I have not configuring with this. This is for last. So now for DHCP service for VLAN 30. So IP DHCP pool V for department HR. Now network will be 192.168.30.0 and IP 255.255 subnet mask. Default router 192.168.30.1 and the DNS server will be 8.8.8. Now IP DHCP pool voice for voice, because we have to also give IP address to this IP phones. The main thing is here is we cannot manually configure IP address to IP phone, so we have to this is necessary that we have to configure our DHCP server for IP phones that can be a router or maybe a specific DHCP server for this IP address allocation. So I'm generally currently here using router as a DHCP server because this network is not huge, so we can use a specific DHCP server because when the IP address is goes from like 1000 above, then we use a DHCP server for a specific IP address allocation. So IP DHCP voice and the network will be 192.168.100.0 255.255.255.0, and the default router will be 192.168.100.1, and here we have to configure option 150 and IP data is on one and one or more IP. Option 150 for same 192.168.100.1. Sorry, the problem is here. Oh, IP. Okay. Now we have to now check here that the IP address is allocated for. Yeah, we can see that this the thing is not shown here. If I will show you, like I have unplugged this IP phone, so you can say it is configuring. The first part is configuring VLAN. So I attach power adapter. You can say this is configuring. VLAN is configured automatically. Now the IP address is configuring in this IP phone. So you can see the IP address is automatically configured to this IP phone. Now it takes time for configuring IP address, about minimum 1 minute. Now after IP address configuration, this asks for the CM list. So CM list is call manager list. So we have to configure a router for a call manager to allocate a specific number for IP phone so that the call will be done. So first we have I'm going to enable the DHCP server, DHCP configuration for all the PCs. DHCP requesting IP address, DHCP successful. Now for this PC, DHCP is successful and 30.2 IP address is allocated. Now for this PC, IP address is allocated, and also IP address is also allocated for these VoIP phones. Now the last thing remain is here the call manager service. So I'm going to configure a call manager service for this IP phone. So I'm going to show here on live that this interface will change when we configure the call manager service. So telephony service. Now there are many options in telephony service. The first thing is here that we have to configure IP address. So IP source address. Now what will be the source address of this IP? So 192.168.100.1. Anything is remains source address, define IP address and port of telephone call. Sorry, IP source address. Now IP source address 192.168.100.1. Now define the port. So for this will be configured on port 2000. Now anything remains? No. Anything problem here? Okay, port. Port. So I'm going to configure port as 2000. Okay, now the thing is done here. Now the remaining is here. Okay, IP phone name, load, last phone registry. Okay. So I'm now going to configure max. Okay. Max ePhones. So maximum ePhones. So the maximum ePhones will be here 6. So the maximum ePhones I have configured as 6, and maximum DN. So maximum DN will be also 6. Now the remain is here auto assign. So we have to auto assign here. So auto assign here directory numbers to those IP phones. So auto assign 1 to 6. So the IP, so the directory number will be auto assigned to 1 to 6. Now exit from here. So which one here? First we check ePhone DN. So ePhone directory number. So here ePhone DN will be first, will be directory number will be first, iPhone will be 1000 or 1000, I can 1001. So yeah, for iPhone DN. Okay, iPhone DN1 and iPhone DN1 and the number will be 1001. Okay. Now exit and uh, as you can see that the phone has registered. Now this phone is IP phone 0, not showing that. I think another IP phone is configured. So number, sorry, ePhone DN2 change state to up and number will be 1002. Now exit and ePhone of ePhone DN3 number will be 1003. So what's the problem here? Do show run. So as we can see, telephony service is enabled. Also assign the IP address port 2000. ePhone DL1 number 123. Now yeah, here you can see that the this phone is assigned for 1001. Not this phone. For this phone, not. I think I have to first of all turn off the power and again turn on the power. We will check for this that the allocated or not. So first of all, ePhone DN4 number will be 1004. Exit and ePhone ePhone directory number 5 and the number will be 1005. Okay, now ePhone DN6 and number will be 1006. Now exit from this. Okay, as you can see that the registered, the phone has registered. Yes, you can see 1002 is registered here. So I have to first of all power on and off all the IP phones for registration. So before that I am going to done one thing more. like ePhone. So ePhone 1, configure it. I am going to configure its type to 7960, and button will be first button for second. Oh, directory already assigned. Second button for 3. Okay, okay, good. Now first we have to power and on off all the switch, off, on, off, on for here, off, on, and off, off, and on. And now in router you can see that automatically directory number will be allocated to all the IP phones. It's taking time. Taking time. Yeah, you can see that socket to IP address 10 was allocated. So if we will see here, so this is registered as 1003. This is registered as 1004. I'm going to give a number here, 1003. The number is not will be permanent, because when we turn off and on the IP phones, then the number will be changed. So we cannot give a specific number for any IP phone. So for temporary purpose, I will assign for this IP phone as a 103. So first of all, check that the PC is able to ping with other its VLAN and the router or not. So IP config. So if you check that this PC is allocated with IP address 192.168.10.2. So this PC's IP address is 10.3. So check the ping 192.168.10.3. So I am going to check in this in simulation mode. So as you can see, the packet will transfer to IP phone, then switch, then one packet goes to the multi-layer switch, and one packet to the next IP phone. And as you can see, the packet is rejected from other switches and routers, and this packet is accepted by this PC, and now the response is generated, and the response is received to the this PC. Now the here thing is, you can see this is the ARP request to this is the ARP request. ARP request, the address resolution protocol, So this protocol is done here to confirm that where is the PC, where is the 192.168.10.3. So when it is configured, or it is confirmed that the where is the PC, where is that IP address. So it is the information is stored in this switch, and when we again ping with this PC, then the packet will not transferred, will not go through this switch, and it's only go to that location. So as you can see, the next packet is the ICMP packet, and the packet is not gone from this interface. This is only gone from this interface. Now the thing is confirmed that, and as you can see that the ping is successful, and also to confirm that 192.168.10.1 simulation mode. Now the ARP request is generated because as you can see in PDU that we don't know the target MAC, we don't know the target MAC address, but we know the target IP address. So when we don't know the target MAC address, MAC address, then it will be the broadcast. So it confirms that where is our packet. So this ARP request goes from this switch, and here is rejected. As you can see, all the switch rejected, and the reply comes from router. Now the next is our ICMP packet goes from. Now here is the thing: if we try to ping with another VLAN or another PC, this is out from this VLAN, so we can't ping with that PC. So if we check 192.168.20.2, we check in simulation mode. Enter. ICMP packet is generated. This goes to this, go to this, go to this, confirm. Now here the replies come back to that port because we have not restrict the that VLAN, and we can also ping with, and this port is also, as we know that this port is also configured as a trunk port, and the restriction is only for the access ports, access in which access port you cannot ping with others. So if 192.168.30.2, and replies come back from that. Now the testing of IP phones. So I am going to an IT member, an IT employees want to call to HR department member. So this is the now this is the phone of IP0 is the phone of IT employee, and IP phone 4 is the phone of HR employee. So if he calls one, the number will be 1005. So if one dials 1005 and enable the call, then you can see that the call is established and this phone is ringing. So if we accept the call is connected. Now if we check that uh, uh, the music is played on this, if we can disconnect the call. Also we can check that if this uh, employee of finance is want to call to HR, the number will be the number is 1006. So the one dials 1006 and establish a call. So you can see the call is ringing.